All right, the last thing we're gonna do today is model these. We're gonna build them. And you're gonna be super careful with my beautiful modeling kits because these are such nice modeling kits and I don't wanna lose any of these. So hopefully yours comes with this little key to what's in here, and it tells you like what color to use for each different element, and then like how many of them there are. So like hydrogen is going to be the little white ones, and then chlorine is the green ones, fluorine's the light green. Now on the whole, it doesn't necessarily matter as long as you grab a central atom that has the right number of holes in it. So there are some that you won't be able to build with these modeling kits because they don't have a center that has the right number of holes. Okay, we have only one that has 5. This one has 5. All right, so that's that piece. These little weirdos are your single bonds. Okay, so you're gonna connect them to your central atom just by pushing one end into your holes, and then you'll grab whatever you're attaching to the other end. So I'm gonna grab a hydrogen. So there's a hydrogen attached to a carbon there. So this represents a single bond. Now, Miss Crane, what if I need to make a double bond? What do I do? Well, for a double bond, you're gonna use these little flexible ones. You're gonna need 2 of them. So you push 1 and 2 into the hole, and then you grab whatever other molecule you need. I'm gonna use an oxygen, okay? And you push 1, and then you fold them over and you push the second one in. So there's your double bond, all right? And I can add some single bonds to this. And I've made CO3, okay? So that's how you do a double bond. What about lone pairs, Miss Crane? How do I do a lone pair? Well, in general, you can just leave that spot empty. You can leave the hole just empty. Or you can put one of these little white guys in the hole to represent your lone pair. All right, so those little white guys represent lone pairs. So go ahead and grab your paper, and we're gonna build the first example here, the NH3. All right, so for nitrogen, according to our little cheat sheet, we're gonna use the blue one for our center atom. We've got 1 lone pair, okay? And then we have 3 hydrogens. So I'm gonna take 3 of the single bonds. Okay, and then I'm gonna attach my hydrogens here. Whoops, you're not gonna do that today. No balls bouncing on the floors, no dropping. I'm gonna go get that in a second. So now the molecular geometry we assigned to this was trigonal pyramidal. And if you look, the base of this is a triangle. And if you put it standing up, it actually creates a little pyramid. So that's why we call it trigonal pyramidal, because it is a triangular pyramid, all right? I'm gonna let you build these on your own. I'm just gonna go ahead and show you a few of the other ones that you're gonna do today and talk about a couple of weird things. All right, so the next one down is the carbon tetrachloride. All right, and we said that the shape here was tetrahedral. So I used a carbon, which is the black one, and then 4 single bonds, and then I used the 4 green chlorines here. Fluorines, light green. Now, the shape here is called tetrahedral. Tetrahedral actually means 4 faces. And if you look, we have 1, 2, 3, 4 faces to this molecule. That's why it's called tetrahedral. So that's the shape. Now I want you guys to notice when I build a tetrahedral, look at how all of the bond angles are the same. That's that Vesper theory, where we're going to spread out as far apart as possible. So these electrons are going to take that 360 degrees around that carbon atom, and they are going to find themselves perfectly equidistant from one another. Okay. The next one that we build is the phosphorus pentafluoride. So we have phosphorus, which we're going to use the purple one for the phosphorus, and then single bonds again. Okay, single bonds again, and then little fluorines on the ends. So now I want to explain what we call this trigonal bipyramidal. So see how in the center of this, we have the triangle. And then I want you to picture like if we built little walls up, there's the top pyramid, and then little walls going down, that's the bottom pyramid. So this is trigonal bipyramidal. It's a pyramid on top and a pyramid on the bottom. Our friend water. I love water. Water is so much fun. Okay, so I use an oxygen in the middle, 2 lone pairs on my water, and then I did 2 single bonds and a hydrogen on each end. So you'll notice that this is definitely something that was linear, that these lone pairs up here push down into a bend shape. All right, so have some fun building these today. Really take a moment to look at the shapes and kind of figure out why we gave them the name we did. See if you can figure out from how it looks when you build it, why we gave it the name we did. And of course, when you're done, please make sure that you put everything back in the box. There are a few that you won't be able to build simply because we don't have the pieces for them, and that's okay. Don't worry about it. If you can't build one of them, that's not gonna be a huge deal. Now, what if I get something stuck in there, Miss Crane? Like this lone pair is really hard to get out. So you have this little tool, you slide it over and you push and pull, and it takes them out really easily, okay? So have some fun with this. Enjoy building the models.